Hi everyone, let's start solving today's lead code question, which is 106. Construct binary tree from in-order and post-order traversal. Okay, let's try to understand the question first. Given two integer arrays, first one is in-order and second one is post-order, where in-order is the in-order traversal of a binary tree and post-order is the post-order traversal of a same tree. Okay, we need to construct a binary tree from these in-order and post-order traversal arrays, and we need to return a tree node. Okay, where the tree node is nothing but the binary tree, constructed binary tree we need to return in this case. So okay, so let start solving this question. So this is in order, this is given as in order, this is given as post order. Okay, so let me try to give you an example what is in order and post order, or what we need in this question. So in order is nothing but left node and right traversal of a tree, and post order is nothing but left, right and node of a traversal of a tree. So what is left, node and right? So like in order traversal, first we traverse all the left nodes, then the root node, then the right subnodes of the tree. In the post order, we traverse first left, then right, then after we process the node itself. Okay, root node. So what I am observing here, that the last index of the post order will always contains my root node. So I can blindly say if I go inside a post order, the last index will always be my root node. So I can blindly say this is my root node. Okay, and this contains a left child and a right child. Okay, so but I don't know in this particular area where the left ends and where the right starts, but I definitely know that from end, the end index will always contains my root node. So for this question we will be needing four parameters, that is starting of in order, ending ending of in order, starting of post order and ending of post order. With the help of these four parameters we can easily solve this question. Okay, so let me write these parameters as well. So SI, SP, and okay, and ending of in order, starting of post order, and ending of post order. Okay, so I don't know what will be my left and right in the post order. I don't know that. So I what I need to find out a boundary between left and right, where the left end and where a right starts. How can I find that boundary? Boundary I can find out with the help of in order traversal, because in order I know the left, before the node, all the nodes which are there, all the elements which are present there, those are the left nodes, and after the node all the nodes present, those are right nodes. तो मुझे इन ऑर्डर से पता चल जाता है कि लेफ्ट कहाँ पे है, राइट कहाँ पे और नोड कहाँ पे है, लेकिन मुझे इन ऑर्डर में नोड नहीं पता था वेयर इज माई नोड वैल्यू. So node I am able to find out from my post order traversal. Now I will iterate my in order. Okay, where my, let me write the index. So where my root node exists in the in order. So I am able to find out that here is my root. So I can write it out as root index. So I'm able to find out the root index. Now I know that root index root index minus 1 minus SO5 will all contains my left nodes. Okay, which will be equal to, I need to find out some boundary of what the left nodes in my post order. So the elements in the left of an in order will be same the left number of nodes in the post order traversal, but I need to find out a boundary here. So boundary minus SP. Can I say this will be equal? So from here, I know the root index, I know the SI, I know the SP. Can I easily able to find out the boundary here? So boundary will be nothing, will be my root index minus 1 minus S of I plus SP. So I'm able to find out the boundary here. So for this example, my boundary somehow will be lie here. Now I know the 3 is my root node. I need to find out the left subproblem and the right subproblem here. Okay. So what will be the left parameter? What will be the parameters of my left subproblem? So if I talk about SI, EI, SP and EP for my left, what will be the SI? SI will be S of I only. That will be starting of in order. What will be my ending index in the in order? That is nothing but root index minus 1. What will be my starting post order index? That will be nothing but SP only. But what will be my ending position in post order? That is boundary. So with the help of this, my left subproblem can be solved. What about the right subtree of the tree? So right subtree will be nothing. Where it can start it? It can start it in here in the in order will be root index plus 1 and ending index of in order. Okay, what will be the starting position of here? Starting position will be boundary plus 1 and what will be my EP? This is very important. EP is very important in case of right part because as I know the post order EP ending position in the post order, the range where I will found where I put my EP in the post order, that will be nothing but note the EP in this case because EP contains the root node that will be EP minus 1. So from here to here only my right subproblem exists. The right node exists in this particular range from boundary plus 1 to EP minus 1, not EP because EP is the root node from EP minus 1. Okay. If I use this four parameters for my left subproblem and right subproblem, my problem can be easily solved. Okay. And what will be my base case here? So I know what is my root node in every subproblem. Root node is nothing. Uh, Post order of EP. Okay. And what is my root index? Root index. If I know the root node, I will iterate the in order and easily find the root index. So iterate in order. What will be my base case? Base case will be nothing. When starting SP will be greater than EP, I can simply return a null. Like there will be no elements. I can simply return a null value. Okay. In this case, my question will be solved. But like what one thing for every subproblem to finding the root index, how can I optimize? Now my solution, I got a solution. I need to optimize. Can I optimize? Yes, I can optimize. To finding the root index, I need to iterate over again and again the in order array. So can I optimize this? Yes, I can optimize using a hash map. So hash map will be nothing, will contain the node values of the in order and the index of it of in order. So in order of one time, I can get the root index. Okay, let me give you a walkthrough of the code as well. So which will be a replica of what we just discussed. Okay. So I created a hash map where hash map just stored the node values of in order and the index of it. Now this is my SI ending index of in order, starting index of post order, ending index of post order. Okay. So this is my base case. Okay, when SP is greater than EP, I will simply return a null. I always know that the post order of EP will will always be my root node, which we just discussed above. Okay, तो रूट नोड हमेशा पोस्ट ऑर्डर का लास्ट इंडेक्स वाला एलिमेंट ही होगा. लास्ट इंडेक्स ऑफ द एलिमेंट से मैं क्या मीन कर रहा हूँ, ईपी, जो भी मेरे सब प्रॉब्लम में हर टाइम चेंज होता रहेगा. ओके, बिकॉज पोस्ट ऑर्डर इज नथिंग लेफ्ट नोड, लेफ्ट राइट and node. So node is nothing but my root node here. So I initialized the root index and I am getting in order of one time my root index in my in order in order array. Okay. Then I going to my left subarray and my right subarray, that I change the parameters here, si to root index minus 1, sp to boundary, and for right subtree, my starting index in order will be root index plus 1. Ending index will be ei only. But in the post order array, my starting position will be boundary plus 1. The boundary we created here with the same problem with the same formula what we discussed above, and ep minus 1. Because why not ep? Because ep is my root node. Okay, so that's it. So I'm thinking like this video will help you a lot. If this video helped you, please like this video and subscribe to my channel. Thank you.